Hi everyone, welcome to the channel. Today we'll be looking at this problem called Reconstruct Itinerary. And if you're new to this channel, what you can find here are software engineering interview questions, the process I go through to solve them, and as well as how to solve various technologies. If you want to see similar content, please follow me on social media for the latest updates. All the links are below. And also check out my website, which has supplementary material and content very similar to the YouTube channel. Without further ado, let's get into it. All right, so for this problem, it's called Reconstruct Itinerary, as I said before, and we're given a list of airline tickets represented by pairs of departure and arrival airports. So we have this list from to, and we want to reconstruct the itinerary in order. All the tickets belong to the man who departs from JFK, so the itinerary needs to begin with JFK. So I have a couple of notes, which if the interviewers don't give us these clarification points, always good to ask. And it says if there are multiple valid itineraries, we return the itinerary with the smallest lexical order when read as a single string. So if we have JFK LGA and JFK LGB, we would have LGA return before LGB. And all airports represented by 3 capital letters IATA code. I'm not familiar with that, or if that's how to pronounce it, let me know in the comments below. Well, also, we assume all tickets form at least one valid itinerary. We'll take a look at one example. So we see here are the list of airports from and then airports to. And because you depart in JFK first, we see there's JFK. There's only one place you could depart to from JFK, or one of the tickets. And so after you go from JFK to MEC, you go to MEC to LHR, and there's only one LHR, so LHR to SFO, and then SFO to SJC, and so that's exactly the order of what you output. And then here we could take a look at one where there's a tie break. So for JFK, there's 2 possible choices. You could go to ATL or you could go to SFO. And so the original tie break for number 1, it says it has to be lexical order. And so for JFK, you choose ATL over SFO. So that's why it's JFK, then ATL. So once you go to ATL, there's also 2 places. You could go to JFK or SFO. And so to follow the rule number 1, where you tie break on lexical order, with lexical order, you choose JFK before SFO. And so if we continue there, then with JFK, go back to JFK. Because we already traveled to ATL, now it has to travel to SFO. And once we're in SFO, we travel to ATL, and then we're done. Or once we're in SFO, then we are done. Yes. Oh, well, once we travel from JFK to SFO, we go from SFO to ATL, and then ATL to SFO, and then we're done. So that's the output right here. And when I started this problem, I thought about a case which made which was interesting edge case, but then I realized later after submitting that this case is not considered in the problem, but I'll present it anyways because I think it's a good thing. It can provide another problem to think about. Also a good clarifying question just to make sure the interviewer is not looking for this case. And so the case I thought about was as follows. Write out the nodes. So we have JFK, and then we have SFO, and we have MUC. And the tickets are as follows. So we have JFK, ATL. Oh, sorry, not ATL. Well, sure. I guess ATL is another airport. So these are the airports. Looks better in my notebook. I can't draw it on this editor, but yeah. So JFK goes ATL, and then JFK goes SFO, SFO, JFK, and you see SFO, SFO. All right. So let me see. Okay, great. So also, it would help if you guys draw this in the notebook. So for each JFK, SFO, MEC, ATL, make it a node. So just draw a circle around it and then draw an arrow from JFK to ATL. So the first airport to the second airport. It will really help you understand what I'm explaining now. And potentially I could throw this, a picture or the image that I drew onto my website so you could check it out. And then if this doesn't make too much sense, you can refer to my website. Yeah, link is in the description below. And so yeah, for this example, we see that because they have to depart from JFK, you choose ATL or SFO. Now, what I thought the solution would be is that we would choose SFO over ATL, because if you choose to go to ATL from JFK, it would be a dead end since there's no way to travel from ATL to the rest of the things in the itinerary. And so for me, I thought the proper way to do this is that we go to JFK, then we go to SFO, reason being that ATL leads to a dead end. Then once we go to SFO, we can follow the tiebreak procedure, which is, yeah, we would choose JFK. Then you go to ATL. Well, I see. I guess that's a dead end. Right. So once you chose, once we're on JFK, we don't choose, once we were in SFO, we also don't choose JFK because it's the same reason why we didn't choose JFK to ATL. It's because it leads to a dead end. So, well, thing is, once you go from SFO to JFK, JFK only has one option, which is to go back to SFO, which is actually, yeah, that is okay. All right, so once we go to SFO, we could go to MUC or JFK. So we'll just go to JFK, and once we're in JFK, it goes to SFO once again. Oh, actually, I'll mark the ones I've traveled to already. I think that's confusing me. So we already did JFK to SFO. Then once we're in SFO, we're choosing between JFK and MUC, which we've chosen to go to JFK. So once we're on JFK, ATL, JFK, SFO, SFO, MUC. Yeah. So we see that once we do JFK to ATL, this also leads to a dead end, which means that we should, when we were at SFO, we should not have chosen JFK over MUC, despite the fact that JFK is earlier in the lexical order. So instead, we should have chosen MUC. And so if we choose MUC, the option we have is to go to SFO. And so we go to SFO. Then we go to JFK. And then lastly, we finish at ATL. So this is what I thought the solution would be for this input case. However, for this problem, the input is actually just JFK. And yes, I know I wrote those arrows and the output should be a list. So these, would be commas. I'll correct it for all the sticklers out there. Yeah, so hopefully the sticklers will be satisfied. And yeah, so this is what I expect, but this is what they actually want. So based off of this example, we know that the way I interpreted the problem was that if there is a solution to the itinerary, which they say there is a guaranteed solution, then it must include every single ticket. But actually, that is incorrect. So they just want you to, at each point, if one single airport has multiple tickets, you just choose the first one in lexical order and then you proceed from there. So the reason why this solution, they want JFK, is because when we're at JFK, right, from the beginning, we can choose ATL or SFO. Because ATL is earlier than SFO in lexical order, we just choose ATL. And once we're at ATL, there's no ticket to go anywhere else, and so the only place that we travel to is JFK, or that we need to be in is JFK. And so that would be the solution to that. But this one, this case with this expectation, I encourage you to think about this some more. I think it's a cool problem to think about. And yeah, if you have a solution to this problem, feel free to post in the link below. And if it was a little bit confusing, I'll explain it more in my website. And yeah, feel free to share solutions or any other edge cases that you think about in the comments here or on the website. All right, well, let's look into the solution that I thought of. All right, so for this one, you know, these kind of problems, traversing a graph, the best thing to do, especially since we know which node to start with, is to have a dictionary. And so dictionary idea we can play with is, for the keys, we have the from, and the value is the to. So our dictionary, we can have JFK, and then we have ATL and SFO. So I'll put SFO then ATL, the reason being that I want to use a default dict, and when I pop, I'll take the rightmost element from the list. And I'm choosing default dict because in case it indexes an empty dictionary, there will not be an error. And the SFO would be JFK Mook. And then for Mook, we have SFO. Well, actually, we should not use this example because this example we just have JFK to ATL, and it's not very, doesn't really show too many cases. So I guess we could just do this original input or our example one, use examples that they give us, and yep. So the dictionary, I'll update. All right, so we have LHR. And LHR, we have SFO. JK, Mook. SFO, we have SJC. Okay, so those are the four. Mook to LHR, JFK to MUC, SFO to SJC, and LHR to SFO. So once we have our dictionary, we know we have to start with JFK. So we could call JFK, and then there might be multiple tickets, so we'll have to iterate through a list. So we get JFK, then we get Mook, then we, for each element, we call function to traverse. And at each point in function, append current airport to itinerary. Okay. Okay. And so we'll have some while loop or a for loop. Actually, I think while loop is better because the list will get modified. Well, I'll check if the while loop or for loop matters. But basically, while we have more airports to travel from current airport, keep calling function. And one other thing is we need to do the lexical order. So the first thing is to sort tickets in decreasing lexical order. And then make the dictionary, and then we call our function. Call our function visit. So if we see here, then we sort based on decreasing lexical order. And well, can't really see the difference in this example because once we put in the dictionary, we're not, we don't have any tie breaks to make. So yeah, I could show the second example where we could see a tie break, but yeah, we can run through the first example and then we'll go through the second example. So for this example, we have, once we sort, then let's see. Okay, so JFK will be first. So we have our tickets. Yeah, essentially this is going to be placed in a dictionary, so dictionary would be random anyways, but yeah, the sorting will matter in the second one. So first thing is we call JFK. So we go visit JFK. So once we visit JFK, then for this while loop, we'll have MUC, and then because there's one element in the list of JFK inside the dictionary, then we will make a function call function to travel. So call function visit. On the current element. So we'll call visit on Muke. And we also want to remove current element. Once you visit there, you want to remove that from the list. And yep, so once we call Muke, then same thing, similar to JFK to Muke. Then we get ALHR, and then we call LHR, and we see there's SFO, and then we call SFO and then SJC. And so each time we'll be appending to the itinerary, and yeah, that's how it works. And each time we are popping it, so once JFK Muke is popped, it will terminate, and we basically go down the level. So once we do visit JFK, then it's visit Muke, visit LHR, visit SFO, visit SJC. And at each point in time here, we remove Muke. So now it's empty. Then we remove, or yeah, that removes Muke, and then remove LHR. Then remove SFO, remove SJC. Once we're in SJC, there's nothing. And defaulted, it was good to use that so we don't get a key error. And so we would terminate, then we would recursively go up these recursive calls. And each point in time we are also appending. So our list here would be JFK. And then our list here, it's including JFK, and then we'll have LHR. Then same thing, or yeah, let's just do this. And then same thing, and then have SFO. And then I'll have SJC. And that's our final itinerary. Actually, sorry, it should be moved down by one. It should have MUC. There you go. So that will be our final itinerary. It has all these elements. And so the one thing to look at is for this case when we have the type break. So an example would be because we sort by lexical order here, then we expect SFO ATL, or what will happen is SFO ATL, oh, sorry, it should be JFK. So JFK, SFO, JFK, SFO, and JFK LTL. This will be the order that we want. So in this example, ATL comes, SFO is placed before ATL, and so that's the order we want originally. But if in the input it was JFK ATL, then JFK SFO, we still want to have this inside tickets, because once we put into our dictionary, we want to see that it's JFK, and then SFO, then ATL, because when we pop from a default dictionary, it will take this element before this element. And that's how we make sure we have the lexical order. So now we talked about the main idea of how the algorithm works and what we would like to create. So now we're able to work on the code. First things first is to make our default dict. And so we do targets equals collections, default dict, and we want a list here. So that way we can keep on adding to the list as we go through. And then we want to sort, like we said here, sort in decreasing lexical order. So AB goes through the keys and values of tickets, and we sort tickets first. By default, it will be in increasing order. So that's why we have to return the reverse list, and so that will give us the decreasing lexical order. And then at each point in time, A is the from, which is the key, and we do plus equals B, which is the value. The destination airport, and this comma is necessary because, well, here's an example. So let's say we do targets of JFK and do plus equals SFO, then the results will be JFK in the dictionary, JFK SF. Yeah, which is not what we want. However, if we do targets JFK plus equals SFO, comma, then we'll get what we want, which is JFK SFO. That's just a little tidbit to be careful about. But yeah, other than that, we can proceed, and we could have this route, which is essentially the itinerary, our list. And so visit a specific airport. So we'll call visit. First thing is to call up JFK. Then we return our route. And because of the recursive call, we will need to reverse our route. And so when we pull up JFK, if JFK, like in this example, has, or the second example has multiple SFO and ATL, then we continue while we have available places to travel to. And then we visit those places. And at the same time, we remove it from the itinerary. That's like right here, the remove MBC, remove LHR. And then we append the current airport to our route. So we got a compile error. Right, so I forgot to do in. So if we do for AB, it is iterating through, but it has to be in sorted whenever we do this. Okay. All right, great. So it looks like the submission worked, or it was accepted at least. And so for runtime, because we need to sort all the tickets, then it will be, if we have n tickets, then it will be n log n. And then for the depth first search that we're doing within visit, we essentially travel to all the places if the itinerary exists. And when the itinerary exists, it includes every single ticket at all the airports, then it will be 2n. So we are making O of 2n calls, which in big O it would just be O of n. And then the time complexity would be, sorry, that was time complexity. The space complexity would be O of 2n, which in big O notation it would just be O of n because we need to store each of the airports along with the places that they travel to in the dictionary. Yep. All right. So hope you guys learned as much as I did and also have fun. And please like and subscribe if you want more content. And yeah, I'll catch you guys all in the next one.